You got it.
Awesome. Yeah. Nice to meet you. How's your day?
Yeah, mine's been pretty good so far. Yours?
Good. Yeah. Yeah. It's been a productive day. I'm on the East Coast, so for me, the day's about to wrap up. Honestly, so I know you have a few interviews ahead of you, right?
Yeah, for sure.
Yeah. Yeah. Why don't you do a little introduction, and I can do one as well, and get started from there. I think you're applying for like a general software engineer. You're not applying for like mobile or anything, right?
That's right.
Yeah. Okay, yeah, awesome.
Yeah.
I mean, I know both of our teams are hiring, but there isn't like a lot of work where you're going to be ending up doing both. So yeah, it's good to know which one you like more.
For sure.
Yeah, I was doing a bunch of like spam detection, machine learning models, data pipelining, things like that. And I'd been primarily working on backend, but all of the code that I like, my main like clients for the service I was writing were mobile. Android. Yeah. So for us for today, it's going to be just like a standard coding interview. I'm sharing a link on in basically like writing a sort of like the beginnings of a test engine. Okay. So the first just like as a framework, test is an 8x8 matrix or like 8x8 board, 8 rows, 8 columns.
Yeah.
The 4 pieces we'll be caring about today are bishops, rooks, knights, and king. So the notable things that we're not caring about are queens and pawns. Okay. Do you know how the pieces move?
Yeah. So we said we're not caring about queens and pawns. So I know with the knight, it's like up. It's like 2 up and 1 to the left and 1 to the right, and similarly down, left and right.
Yeah.
Yeah.
And then bishops diagonals, rooks vertical, horizontal lines.
Yeah.
King can just move 1 square in any direction. So those are like the 4 pieces we care about. And so the first method that you want to write is just given this chessboard, and let's just define. Let's say we can think of these pieces as letters. So you have a bishop, a rook, we'll call it knight and n, and then the king. So these are like 4 pieces, and then you might have some board, which is going to be like a 2D array, and then any square where we have a piece, we'll just label it. Okay. And then the other thing to note is you also need to know colors, right? So you're going to have like a white bishop or a black bishop. Okay. And so that's kind of how you'll be given a board. And so this would be like the first row, and obviously like this will be white king or something, etc. So this is what our board looks like. And then given a board like this, you want to build a function that returns true if the king is in check. So
sorry, what is WK again?
White king.
Okay, I see. Oh, for the 2 sides.
Yeah. So you get something like the board, and then color. And color can be like white or black, or like W or black. And then you want to like, given these 2 things, you want to see if whatever color it is, if the king in that color is in check. So if you get white, you have to see if the white king on the board is in check by any of the black pieces.
Okay. Okay, sounds reasonable enough. Let me go through this again. So let me sort of write these out so I know. I'm gonna have to sort of map what each thing does. So bishop, rook, knight, and king. The bishop, diagonally, rook, vertically, or horizontally, knight, L-shape movements, then the king, 1 square. So the king is tricky in the, I guess it depends on the turn. Because I would imagine if 2 kings are next to each other, then they're technically both in check, but I guess you define check by whose turn it is. So it would be the other check king that's in check.
Yeah, I agree. I think there's going to be some edge cases, some like illegal positions of the board. Like technically like 2 kings could never really be next to each other.
So the board given to me already. I just need to evaluate in that order if the king is in check.
Right.
Okay, so let me see. How do I want to do that? So if you're given some king position and you go through. So what I need to know is first off the position of the king, and if the color is white, we're trying to see if the black king is in check.
No, it's opposite. White. If the color is white, then we want to know the white king is
Okay,
in check.
so that word. Okay, so color being white means technically the other color's turn it is. So they're trying to see if they could. Okay,
Yeah.
I get it. So position of the king. Input color. And to get the position of the king, I imagine you can just search through the board and just see where. Yeah, I just do a typical iteration. So iterate through board and of n times m time. It says 8 by 8, so I guess in the chessboard the n and m are always the same.
Yep.
So n squared time, iterate through board and n squared time until king is found. All right, so I need to know the position of the king. I need to know the position of all the pieces. Do I need to know the position of all the pieces? Let me write it up for now. So the positions of all other pieces. And that technically still goes on the iteration. So I can do in one pass, I can just keep track of all the pieces. I can say, I want to do a map. Let me think. If I have multiple of these, how would I represent that? I can have a list of, let me think. How do I represent these? I'll come back to representation after. So for each of them, iterate through the board, figure out the position of the king, figure out the positions of all the other pieces. After that, I need to get the moves of all the pieces. So get moves of all other pieces. And then from there, I want to see if king's position intersects with any other pieces' potential moves. Okay, so go through the board, get the king position, figure out where all the pieces can move, see if any of those coincide with the king's position. All right, so that sounds fairly straightforward to me. So I just saw stage 2, and it mentions checkmate. So
Yeah.
So check means the king has to move, otherwise the next turn is a checkmate, right? Just verifying.
Yeah. So check just means that
If they don't move this turn, then they automatically checkmate the next turn because some piece could then checkmate it.
yeah, basically there's no place for the king to go anywhere. So that's why it's a checkmate.
Yeah. Okay, that's fair. All right. So if it's in check, so go through, see if any of these. Okay. Yeah. See if it coincides with any of these in this composition. All right. So yeah, I think this covers everything. I want to see in terms of the algorithm how I want to solve this. So how do I want to represent? If I have this, I have these. Do any of these coincide? And there are obviously edge cases because if I get moves of all of the pieces, I have to take into account other pieces in the way. Because if something can go fully vertically, if there's another piece in front of it, then that's obviously as far as it can go. So I have to take all of those into account. So if we have this piece, okay, so I want to do some mapping. For each piece, I want to know its position and all the positions it can go to. So if I did a map where I had some ID of the piece, so that's what I want to know. So the piece type, where it is, where it can move. And where it can move sort of depends on where the other pieces are as well. So let me see. Interesting one. Let me think through it a bit. How much do you care about optimality?
Not very much, honestly.
Okay.
Yeah.
All right, let me think. What's the best way to go about this? So now I'm right here. I guess. Yeah, the knight one is tricky. I guess something I could do, instead of checking all the possible moves of the pieces, I can just check from the king itself and see if the king is here, if I check horizontally and vertically, the only thing that could hurt the king horizontally and vertically would be rook. So if horizontally and vertically to the king, if there are no rooks, those are fine. Then I check diagonally from the king. If there are no bishops, that's fine. If one square away from the king, there are no other kings, then I'm fine. And if L shape away from the king, there are no knights, then I'm fine. So that's another way I can do it. So before I was thinking to get all the moves for all the pieces and see if the king intersects with those. But I think something that might be easier and probably better for complexity as well is if I just take where the king's position is, and then I say from that king's position, if any of the other pieces, horizontally, vertically, diagonally, or L-shape away from that position, if there is any piece there, then we know if it is in check. How does that sound?
Yeah, sounds good. It makes sense to me.
Position if reachable. All right, so let me go with that approach. So first I need to know then what the king's position is. So king is equal to none for range board range. I would assume the board will always be non-empty.
Yeah, like you can just assume legal positions. Like you don't have to worry about edge cases too much.
So, and a board you said is a WK. That's what I'm checking for. I mean, not a board, a king.
Depending on the color, yeah.
Okay. Okay. Let me take that into account. Let's say chess mappings equals to. So we say WK is, so that is 0. Let's just, it's a king. How do I represent it? Can I use some enum? I'll come back to the mapping for now. So if board I j is equal to, so first I need to know the color. So get the WK, okay. Okay, so if color is equal to, so the color is either W or black. So W equal to that, and one equal to WK, or if color is equal to B and board I is equal to BK. So if color is white and we're at WK, and the color is black, and I don't need to sit here. To that, so king position is equal to IJ. So now from the king position, I can figure out everything horizontal, everything vertical, diagonal. Okay, so it's horizontal, check for rook and king. Vertical, check for rook and let me say other king. Other king, and then diagonal, check for bishop and other king, and then L-shaped, check for knight. All right, so let's do horizontal first. So the position here, so we have the king position. So we'll do to the left and to the right. So let's say left and then right. Similarly for vertical, I'm going to want to do up and then down. For diagonal, I'll do top left and then bottom right. So for left, I want to say, so while check all the way in one direction. I'm going to check all the way in one direction while index equals to king position 0. So I get the I. So which one is this? I 0, 1, 2. Oh no, I is the row. So I need the yeah, so this one should be J. So that index next one. So go one over and then plus 1. So while left index is greater than 0, I'm going to do the same thing. While right index is less than position length of board. So for less index, so while if it's greater than 0, let's say if should be 1, should be 1, because that's the coordinate. So if board is king position 0, and then left index, so board look to go through, that is equal to, I have to check either for a king in the first, because a king can only move 1. So in the first check, let's say counter equals to 0, because I'm going to return that each time. If this is equal to, I guess which one is the king? So I'll need to know the other king. Other king equals to none. If color is equal to W, other king equals to king, else king equals to other king. So counter 0, so board is equal to, let me check for rook first. So if I do this, I do that, left index. So if this is equal to, which one's the rook? I'm gonna need to white, and that one's black. That's a good thing I could do. All of these are whites. So here's white equals to color is equal to W. So forward king position left index. So if is white, if is white, then if it's white, and I check the king position to the left is equal to, is it white rook WR? If it's equal to that, then return true. It is a check. If not return true, and if counter is equal to 0, and it's other king. It's other king. That should be set equal to other king, and turn true again. I want to do something for else. If it's not white, it's not white. I want to do the flip for. Okay, this one should be able to just come down here. So if it's not white, then I want to check that equal to black rook. And then that's true. So if it's equal to that, oh, this one should be Aleph. If that's equal to that, return true. It's white. Oh wait, no, this one, if it's this one's black. False. So I'll do that, once that, then do that. If counter is 0, and that, and then return true. Otherwise, I want to do counter plus equals to 1. And at the end, I want to make sure to always reset counter equals to 0. So you go all the way to left for a bit left index. Index minus equals to 1. Keep pushing left index. So if that one's equal to white rook, it's white. Nice. So I want to duplicate this for the right. This one down. Put it next. Right. Position 0. So right index, right index, right index, and right index. Now it's plus equals to 1. So that should handle left. That should handle right. I want to do up and down. Up. And then I want to do it for down. So it's going to be up index. This one should be 0. Minus 1. Index. And this one should be. Okay, so I had to issue the brackets right here. No, that one. Oh, I have to close this. Close that. Close that. Close this. Close this. Close this. What is the syntax error coming in? Yeah, I don't need to. Yeah, those are fine. For this one, the first one should be up, and this one should be 1. So this one should be 1, and should be up index, and 1. Index 1. Position. Index 1. Index. Oh, this part should be king position. This should be king position that. And then this should be king position that. These. That. Okay. And then counter. So yeah, plus 1 similarly. And then up index is minus equal to 1. And down. This one should be greater than 0. Up should be greater than 0. That's that. How are you going down? Down index, down index, down index. And down index plus equals to 1. So it should be left, right, up, down. And then for diagonal, it should be top left, bottom right. Okay. So just thinking out loud, this feels like it's taking longer than expected, because if this is a 45-minute problem and there are 3 stages, I feel like there should be a faster way to do this, because just checking the up, down, left, and right is going to take up the whole time. And for there to be two more stages, that means there should be a simpler way to do this.
Yeah, I mean the third stage is like that's an optional stage, so that's fine. I think overall,
because this works, the challenge just takes longer to check all the rights, the down, the left, the right. I feel like there should be a faster way to do this.
Yeah. So what part do you think we could?
Yeah, I could probably just write some separate helper method that would just pass in the values. So this whole while loop, each of these checks, I wouldn't have to copy and paste all of this.
Yeah, like so. I guess the main
the direction
then is like what part is like what is really changing between each of them.
Yeah, the challenge is because I'm also checking the king in these with the counter, which probably overcomplicates it. That makes it hard to separate out into helper function. So I'm already halfway through, so I'll just continue.
That's okay. Yeah, I mean, yeah, we can also. I think overall like this will work. The main what is the counter counting? That was like
the counter is just for checking the king because the other king can check a king if it's in the 8 positions around it. Since I'm already checking those 8 positions for the other pieces, I figured I could cut down time by checking the 8 positions for the king just for the first check. So for the rook, 1 left, 1 right, 1 up, 1 down, 1 diagonal in each 4 directions. All of those 8 positions will correspond to a king, as well as one of the other special pieces. So instead of checking the king separately for 8 pieces, I figured I'd just check it for the first time.
I guess so if we were to remove the constraint, like if we were to say a king can't check a king, would it make a lot simpler?
Yeah, then I would just get rid of the counters, and then
what would be different, I guess, because this is, as you said, now you're just going to be doing a bunch of copy pasting, right?
Exactly. So for stage 2, if it says build a function that returns true if the king is in checkmate. So checkmate means the king has no positions to move to without being in check, essentially. So no positions to move to. So essentially, the king has 8 possible moves it can make, and so you have to check each of those 8 positions. And the first thing you'd have to check is any of those positions occupied. So if there's already a piece there, it can't move there, so that you have to filter those out. So filter out immovable spaces. That's the first thing. So after you filter out what you can move to, then you take the ones that you can move to, and essentially you would just run my isCheck function for each of the remaining moves. So run isCheck on the remaining movable positions. So what that essentially means is, let's say there's no piece around the king. If the king can go up, down, left, right, diagonal, whichever one, if the king moves there, if we run isCheck on that board where the king is in that position, isCheck would tell us if it's in check. And if it is check, if it's true, after you run all of these, then you know it's a checkmate. So essentially it'd say return true if all isCheck is true, else return false. If any of these isCheck is false, then you know that's at least one position the king can move to. And so that would be false for checkmate. Otherwise, if all the isChecks say true, then it is a checkmate.
Yeah, that makes sense. And then just as a thought experiment, let's say if we didn't want to, so right now we'll be calling isCheck, let's say in the worst case, 8 times, right? Let's say all squares are unoccupied.
Yeah, which right now would be n squared. So that would just be n squared because 8 is a constant number of times.
Yeah, so, but it compounds, right? So essentially what we're doing like n squared while loops for 4 n squared while loops for each piece on the board. Or sorry, so there's gonna be, I think that you're right that the big O would be fine.
Yeah.
But I guess my main question was, do you think there could be a way we could combine the 8 isCheck calls into one call without having to?
Yeah. When the 8 isCheck calls into one call. So I imagine something I could do is, another thing I could do is if I can either mark the board or make a copy of the board. So let's say mark/make copy of board, and I can essentially just fill in all the positions of all of the pieces. So, and fill in positions all other pieces can move into. So essentially what that means is if I have a rook, if I have a bishop, all of those, I just go for each piece and I just mark all the places they can go. So when I run if it's a checkmate function, I just need to check in the 8 positions. I don't have to run my isCheck function. I can just check if the position I'm moving to is already a marked position, in which case you can't move there. So then I wouldn't have to run isCheck 8 times.
Yeah, that's perfect. Yeah, correct. We can just store state onto the board and then only have to go through the board one time.
Yeah, exactly.
Yeah. Okay, that makes sense. And then we have maybe 1 minute or so. If you didn't have a counter, do you think you can see a way we could standardize these while loops?
Yeah. So if I were to standardize these while loops without his counter, if I said some define check. Here. So the board, because then I can get the size of it. The direction index, or to direction. What else? Current index. So the board, you can check the board size. That's where I know if it's less than the size of whatever board is being passed in. The direction, meaning, am I going up? Am I going left? Am I going right, down, diagonal? And the index. So if the index is 5.3, and I know my direction is up, then I know I'm only modifying the y. If I know it's down, I know I'm modifying the y in this direction. Similarly, if the current index is anything else, 2.6, and I know the direction is left, then I know I'm only modifying the x to the left, and then the y to the left. So in that case, if direction is equal to, so I would have some direction for each of them. Then we go pass. And then so passes, and I need a
Do you think we could represent the directions in a way that you would need the if, that like the direction itself would encode the
I could probably
information?
just have some list of like current position, so like a -1, 0.
Yeah,
left,
perfect. Okay. Yeah, I think
1.
that sounds perfect because you can now you can just pass this in, and then this would work for all positions actually.
Exactly.
Like this would work for your bishops, rooks.
Yeah.
Yeah. Okay. Awesome. Okay, that's all I had for today. Do you have any questions? Absolutely. So for me, I've been working on the marketplace team for the last few months. When I joined, we honestly didn't even like really have a very strong team structure. We just had like a back end, front end, mobile team, etc.
Yeah.
And then over the last few months, around May of this year, we like really solidified into vertical teams. So I'm on marketplace now, which basically means all of the liquidity, like so any like flows that allow you to buy, sell, list, look at orders, anything related to all the order flows, and then integrating with the actual like blockchain to be able to have user actions be converted into actions on the blockchain. Like those kind of integrations is what the team works on. For the last month or so, actually, my main project has been building analytics. So like doing a lot of like data profiling on the site so that we can like allow create insights for users.
Yeah.
And then day to day, it's much more relaxed. For a long time, it used to be a lot of firefighting.
Yeah.
But now like we have gotten to a place where like our platform is really stable. You don't really like get paged very much, if at all. So mostly it's going to just be like there's going to be some emergent work, but I'd say like probably like 60 to 70% of the day you're working on the main task that you have for the week.
Yeah.
And then for like for the other times you might have some emergent bugs, like you might have some questions, you might have people like looking for feedback on design. And so there's lots of big projects like coming through the pipeline at the company, and because everyone is pretty new, there's a lot of like just like ownership you can have and like feedback you can provide like on a design and architecture perspective of a lot of the services we're building.
Hey, good. How are you doing?
Yeah, I'm gonna step out. Nice meeting you.